This screencast will look at Earth's temperature and Earth's carbon dioxide value from the present date back in time to about 550 million years ago. Before getting started, let's take a look at the chart layout. There's a line here, you can see it right here. This is the representation of the present average Earth temperature today. This scale here shows you deviations from the present in degrees Fahrenheit, where the average was determined by averaging Earth temperature for the period 1960 to 1990. And the blue squiggle line you see here is actually the temperature as determined from ice cores that were pulled from both the Antarctic and the Greenland ice caps. Ice cores, because of the gases trapped in the ice, provide very accurate reading of historical temperatures and carbon dioxide. Again, the blue line will indicate on this chart Earth's temperatures. Up here there's a green line. This green line indicates carbon dioxide levels in the atmosphere. It'll cover the same period of time. And the gauge here on the left here is the scale for the carbon dioxide line. The line that you see here is at the value of 180, which is about as low as it's been over the last 800,000 years. For most of the last 800,000 years the carbon dioxide did not at above 280, but in recent 200 years it is eased up to where it's currently 410 parts per million in 2023. This is against the Earth's average temperature being 1 degree Fahrenheit above what it historically used to be again, and that was in 2023. Now we'll be looking at a number of panels in this chart to get a feel for how things have changed over time. This particular chart covers 20,000 years. The present time is on the left, and back here on the far right edge that's 20,000 years ago. These little blue squares here indicate where the X time is in the temperature scale. In this case it is at the present date. It can be moved. And this little panel here indicates that the Earth geologically is currently in an ice age period. Now geologically, an ice age is defined as a state where ice sheets are present on one or both of Earth's poles. The Earth entered its current ice age actually about 33 million years ago when the South Pole developed a permanent ice sheet. On or about 2.6 million years ago Greenland also developed a permanent ice sheet. Accordingly, during the period of time the Earth has had permanent ice sheets at the poles, there have also been many periods of what is called glaciation, where glaciers would form all over the northern hemisphere and advance over the northern continents like North America, Europe and Asia. Those ice sheets would advance, grow very large, cover large areas, and then they would eventually reverse and melt away slowly. The main purpose of this screencast is to demonstrate the correlation between Earth's temperature, again here in blue, with carbon dioxide levels in the atmosphere. This is for informational purposes only. There is a lot of speculation that carbon dioxide levels drive temperature levels. Alternatively, temperature levels have also been assumed to drive carbon dioxide levels. As you can see from the little panel here at the bottom, this first chart we're looking at covers 20,000 years from present on the left to 20,000 years ago on the right. Current average temperature is represented as 0 on the temperature scale here. You can see that line going across here. What I'll do next is advance the X, which basically rides along the Earth temperature line, to the beginning of the next panel. And so we'll make that happen now. And there it goes. This second panel covers a period of time of 980,000 years, basically from 20,000 years ago where we left off in the first chart back in time to 1 million years ago. Again, Earth's temperature is shown on this bottom graph. The first part of it is blue. The last 200,000 years are in black. The top chart here is the carbon dioxide values. They are in this blue-green color. They go from 20,000 years ago when they stopped at 800,000 years ago, which is where the data from the ice core stops. I'll point out that the temperature here and again here the 0 line goes up and down depending upon glaciers advancing and retreating in the northern hemisphere. This chart starts at 20,000 years ago, and 20,000 years ago was when the most recent glacial maximum occurred. Glacial maximum is when the glacial advance in the northern hemisphere was as great as it was going to get during that cycle. The glaciers had spread in North America all the way down into such states as New York, Iowa, Wisconsin, Wyoming, and South Dakota, and in some places they were almost 2 miles thick. So that's a lot of ice. Now I'll point out that for these peaks and valleys they occur fairly regularly. These cycles are called Milankovic cycles. They occur about once every 100,000 years, and they have primarily been caused during the past 2.5 million years ago by the Earth's orbit going around the Sun. That seems to have been the primary driver of Earth's temperature and the advancement and retreat of glaciers in North America, as well as the levels of carbon dioxide in the atmosphere. Basically, as temperature goes up, carbon dioxide tends to go up. As temperatures go down, carbon dioxide levels tend to go down. In fact, there's a fairly strong correlation that ice ages over the history of Earth, and they go back a long way, not continuously. But in certain periods of time, ice ages have primarily started when carbon dioxide levels drop to low levels in the atmosphere. The loss in carbon dioxide causes the Earth to really cool down and ice ages develop. Again, note the zero or present temperature line here. I'll also point out that during the last interglacial period, and an interglacial period is the warmest period of time between the maximum of a glacier and when it melts away. The last interglacial, about 125,000 years ago, presented Earth with an average temperature that was 5 degrees Fahrenheit warmer than today's average. Currently the Earth is running maybe 1 degree above the average between 1960 and 1990, but 125,000 years ago, the last time the glaciers retreated, Earth was running 5 degrees warmer. If you look at the carbon dioxide curve here, you'll see that the peaks and valleys correspond generally with the peaks and valleys in the temperature curve. They don't match exactly. Nobody knows why, but they're somewhat aligned with each other. What we're going to do now is advance the X and let it ride along the temperature curve and see where we go here. So we'll start it riding and we'll let it go, and we'll stop it when we get to the next chart. You can see the time period advancing very rapidly. Okay, we're now in the next chart. At this point I've taken us back to the previous chart for a brief moment. I've placed the X at the 800,000 year point, the next block 800,000 going forward. And I want to point out that the carbon dioxide chart changed here. And that's because the previous carbon dioxide chart came from ice cores, and there's no values available after 800,000 years. However, there's a new chart available. This chart is really scaled out. The period of time from 800,000 years here to 1 million years here, end of this particular chart, is represented up here in the upper left corner on this blue new carbon dioxide chart. This little red splotch you see here is a period of 200,000 years represented by this span in time. And if I zoom in a little bit, you can see that the red spots here pretty narrow corresponds with a lot of deviation seen in the carbon dioxide values of the upper chart. I point that out because this chart is going to be displayed over the next several panels, and it will be the same, but its correlation with the current chart, in this case the time period from here to here, will be represented by the area over a red line here that you see on the carbon dioxide chart. Also, I'll point out that the scale available for carbon dioxide has changed, and you'll see that over the period of time of this chart, which we'll see in a short while, the carbon dioxide level in the atmosphere goes up dramatically as we go back in time. I've advanced us to the beginning of the next chart. This particular chart covers a period of 4.5 million years, or from a time period on the left of 1 million years ago, which is where the previous chart ended, to 5.5 million years ago, all the way over here on the right side. Notice the temperature line here is now depicted in black, and it jiggles up and down, but as a general rule it also climbs slowly throughout this period of time. Again, this line along here is the zero deviation or comparison to the current average temperature of the Earth. As previously mentioned, the carbon dioxide in this chart that corresponds to this period of time here, this 4.5 million years, is represented by this red line you see here. So you can see the carbon dioxide go down and then go up gradually during this 4.5 million years, and it went up to levels that are 4.5 million years ago, basically the same as they are today at 410 parts per million. I'll also point out that at about here this is the maybe 2.8 million range. This is when the Earth entered the portion of the current ice age where Greenland developed its ice sheet, Antarctica already had one. Again it showed up 33 million years ago, but Greenland picked its ice cap up about 2.5 million years ago, and these jiggles in the temperature here are also caused by Milankovitch cycles. These are also due to the Earth's orbit around the Sun. But in this case, instead of having an oscillation period of about 100,000 years, these guys oscillate on a period of about 41,000 years, which is the same oscillation period that Earth's axis still changes as the Earth goes around the Sun. So basically a different Milankovitch cycle was in play for this period of time here, a period of time when the Milankovitch cycles were taking over. We picked up an ice sheet in Greenland, so Earth got colder. As you can see from the line here, average Earth temperature dropped below the present average and stayed there for this entire period of time. Let me go back to the previous chart. It was only when the 100,000-year cycles kicked in did we start beginning maybe the last 400,000 years actually get above average temperatures here in the Earth. I want to point out that the Earth has basically been much colder than it is today over much of the past 2.5 million years of history. And I'll also point out that Earth's temperature dropped below today's average by maybe 3 degrees Fahrenheit along here, even though carbon dioxide in the atmosphere stayed very close to today's very high level. Again, 280 was the pre-industrial average we were looking at. We're way up here close to 350 to 400. So high carbon dioxide here still gave us low average Earth temperature, and again during this period of time glaciers were advancing and retreating all the time in the northern hemisphere. Now at this point what I'm going to do is advance the X along the temperature curve until we get to the next chart. I didn't bother to have the X trace all the ups and downs, there are just too many of them, but you can see by the deviations in the black curve that Earth's temperature was constantly dropping and raising again due to Milankovitch cycles and advancing and retreating of ice sheets in the northern hemisphere. Okay, we've advanced to the next chart. I've jumped us back to the end of the previous chart. I want to point out that at about 5.5 million years ago Earth's average temperature was running 5 degrees Fahrenheit above the 1960 to 1990 average, so the Earth was a whole lot warmer than it is today. We go to the next chart. We're starting off at about 5 degrees above normal, and as you can see from the temperature chart, which is green in this case, going to stay constantly above our current temperature above the zero again as we go back in time substantially warmer. This particular chart covers the period of time of 59.5 million years, basically taking us from 5.5 million years ago on the left to 66 million years ago on the right. 66 million years ago was when the dinosaurs were killed off when the asteroid hit the Earth. We're in what I call the green chart, and I use the colors to refer to the charts because that's the colors that were on the temperature curve. In this chart we're going to go from 5.5 million years on the left to 66 million years ago on the right. And the carbon dioxide chart you see up here that corresponds to this time range here is the area over this red line here. So you can see that carbon dioxide is here in the peaks that you see here and here, and even the spike here that correlate very accurately as we go down here. But again, I'm going to point out that carbon dioxide levels are already well above today's average. Here we're looking at 5.5 million years ago, maybe 550 or something. Notice how they go way up to almost 1000, drop back down to maybe 600, and they end up being at 1500 and perhaps even higher. It's somewhere around, I'm guessing, 57 million years ago. Again, temperature and carbon dioxide follow each other, but the cause and effect has not been agreed upon. By the way, I've temporarily taken this back to the end of the previous chart just to point out that in the current ice age I'm only indicating that Antarctica has an ice sheet at this time. Greenland did not pick up its ice sheet until about here in time. So this period of time here only had an ice sheet in the southern hemisphere over the South Pole. If we go back to the beginning of this period of time, notice that Antarctica has an ice sheet when we're at the beginning here at 5.5 million years ago, and it still has an ice sheet, but it too is going to disappear when the time advances to around 33 million years ago, which is going to be somewhere around here. Again, note that Earth's temperature in the green line here is substantially higher than today's values, going up to about 25 degrees Fahrenheit above current values maybe 50 million years ago. It was a much warmer Earth during this period of time. What I'm going to do now is advance the X along this curve. I'll do it manually until we get to the next panel. So let's see how we do. It's not going to be smooth, but you'll get the idea. And temperature went up and we're in the next chart. Now I'm going to point out that we have a different graph for carbon dioxide here going from 66 million years ago back on the left side here. And by the way, this chart will cover 485 million years. It will end on the right at about 550 million years ago. But I'll point out that the carbon dioxide chart changed to this multiple line looking guy here as well as the new temperature curve. The temperature curve in this chart is yellow. It goes up and down quite a bit. Again, we have our zero line here for temperature, and only for one period of time in this whole span did the Earth's temperature get down to near our present range. And in fact, you're going to find that there are other ice ages here. In fact, if we go back to the previous chart, note that there are no ice ages here indicated. That's because we're sitting at about 66 million years here. So if I'm going to scrape back here and see if I can locate where our ice age popped up, there it is. It's about 33 million years ago. And what I'm going to do here is just manually advance the temperature X along the yellow curve, and let's see if we can pick up when ice ages are going to show up again. As I recall, they're going to show up around here when this big drop happened in temperature and it finally went down to today's temperature a little bit lower, and another is going to happen over here as I recall. And this is going to happen as an ice age even though the average Earth temperature was way above what it is today. And that's going to be having something to do with the position of the continents at that time. Let's go ahead and try to manually advance here. See how we're doing, keeping an eye on any pop-up of indication of an ice age. Temperature is going way up here. I think we're running almost 20 degrees above today's average. Look at all of a sudden way down something happened. Here's an ice age popping in right here. So an ice age is now happening, and this is going to run all the way through this period of time. So that's going to be a pretty good chunk of time. I think about 100 million years it's gone from 360 to 260. That's 100 million years. That's a long ice age. Only here during this span did the temperature of the Earth drop down to where we've seen it during our current recent ice age period. Before and after that, Earth's temperature was way above where it is today. So we're going to keep trucking along here. And if you notice, when we get about here, here's the other ice age. This one happened for about 30 million years. Not real long, but it happened during the period of time with Earth's average temperature, and that's up here maybe 15 degrees above today, was a lot higher, and yet we still had an ice age on the Earth. Again, I think that was due to position of some of the continents around the globe, which is nothing like they are today. We'll continue this on down, and we're now at the very end of the chart, about 550 million years in the past. And as you can see, temperature is way up around 22 to 23 degrees above current. But carbon dioxide is off the charts. It's at 6,000, and again it's currently 410 in today's climate here on the Earth. The history of Earth's temperature versus carbon dioxide is quite a trip, and if we scrub back, things change a lot. But the point I want to make is that for the last maybe million years we've been living in a much colder climate again, which was primarily caused by the Earth's orbit around the Sun. We've been living in a period of extreme cold compared to most of Earth's history. And I've done this chart in a period from present to back 550 million years ago because that's the period of time when life on Earth really advanced, got very complex, became very prevalent. Everything happened: dinosaurs, birds, fish, mammals, humans, you name it. So high temperatures were not all bad, and we need to be concerned about fact that during this period of time, the last 20,000 years, it's been real cold for half of that. This is about 11,000 years ago here. We've done well because glaciers have been melting, but we haven't been around living in North America for much more than about 15,000 years, and there have been really big glaciers up here that would have been a problem for us to live around. And if we go back in time through all these Milankovitch cycles, even considering the brief warm periods of time, these glacial advances mean that mankind could not have been living anywhere in the northern hemisphere for all practical purposes above about 40 degrees north latitude. And that's because the glaciers were covering all the land up there. And just something to keep in mind, we may be living in a nice warm period right now. It was estimated, if you look at this cycle and the duration of these interglacials, which tend to go between 10 and 15,000 years, that's the amount of time when the interglacial periods last and it's warm. We should have been entering our next cooling period about 6,000 years ago based on past cycles. And as a matter of fact, the Earth did start cooling at that point in time. However, it is now assumed that mankind's use of agriculture, which increases carbon dioxide, and the burning of fossil fuels, which also increases carbon dioxide, that we may have benefited ourselves by doing that, because it's possible that we may have postponed the start of the next glacial advance by maybe 50,000 years. And that's not bad in my opinion.